All right, hey guys, how's it going? I'm Zach Allen. I'm with Slate Robotics. Today we're going to be talking about how to upload and change the firmware, the code that's running directly on the TR2 actuators. This will be done with just this actuator right here, just for simplicity's sake. You can do this directly on the TR2 arm. You don't have to disassemble it. You'll notice that there is a little back port right here on the actuator. Every single one will have this, and all you need is just a little USB micro. Was it USB-B? I don't know. It's the small ones that you use with Android. They're used on everything. So you just plug it into. Let me see if I can get that there. You'll see there's a little. It's actually an STM32 microcontroller. You just plug that in. Would be best to not have any power connected to it. So if you're doing some uploading, I would recommend turning your TR2 off completely. And what we're going to do is go ahead and plug this into the computer, just like that. You can see our computer has already detected that. Actually, you can't see because you can only see one of my screens. All right, so that's step number one. I'm going to walk through. I haven't actually installed all of the software or any of the software on this computer, which makes it great for doing this tutorial. So I'm going to go through. We're going to need Arduino. We're going to need to install these STM32 Arduino packages. And then lastly, we're going to need to pull the code from our custom code that runs on it. And then upload that to the actuator. So it's really a three-step process. I haven't done this at all on this computer, so that makes it great. So hopefully I can run into any issues that you guys potentially might run into and be able to solve them for you. It's really pretty easy. I've had some issues with some computers every now and then, not having drivers or something or another, but I don't think... Anyway, it's really pretty easy. So we're gonna get the Windows app. Just download. Right, I have to go through the Windows Microsoft Store. Hopefully, it doesn't ask me for credentials while I'm recording. And I'm gonna do this all in just one take. So if I have problems, you guys will see those problems, unless I run into something just ridiculously crazy. I don't know, that I need to do something crazy, and I'll turn it off and pause the recording. So we're just going to download the Arduino IDE. I'm sure a lot of you guys already have this installed on your computer. So yeah, the actuators, they just use C++ Arduino code. You know, it borrows a lot of the same functionality that you get out of the Arduino IDE. And this STM32 Arduino is just a Arduino port for the an STM32 port for the Arduino that allows you to just use the same interface that you typically do with the Arduino. So it's really pretty easy to get going. We're cooking at 9.8 megabytes per second. That's pretty nice. So once this downloads, we're going to pull this open. We're going to go to that package manager section. We're just going to throw in one little link. I'll put all of these links for that I'm using here in this video today down in the description. And yeah, we're just going to throw in the STM32 link that will automatically go out and grab those packages for programming with it. We're going to clone the TR2 embedded repository, and we'll do a quick little upload, you know, and show you can make some pretty easy changes to it. Just a lack of that. Cool. Almost done. Sorry if the background noise is kind of loud. I've got the 3D printers going like crazy. Okay, Arduino IDE. See if we can open it. No, not yet. Launch. There we go. It's opening on the other page. Just a second. Allow access. There we are. Cool. That is what you should see. I'll go ahead and go back here just so that I make sure I keep track of all the links we used. So this is the Arduino IDE. In case you guys haven't seen it before, this is what you typically use if you just like buy a little Arduino Nano or Arduino Uno. This is what you're going to use to upload it. But we can use that for our STM32 by making just some small adjustments to the configuration. All right, so here we have github.com/stm32duino/Arduino Core STM32. I'll have this link down in the description. And all we need to do is go down here to this Getting Started section. And we just need to copy this link. You can see, use this link in the Additional Boards Manager URLs field. We're going to copy that. Copy that. Go to Preferences, and then right down here, you'll see Additional Boards Manager URL. We'll just paste in that link, click OK, and let's see. There is something else I need to do here. It's usable with the Arduino Boards Manager. Here we go. So then we're going to click Tools. We're going to go down to Board, and then we're going to go to Boards Manager. I'm doing very well so far. STM is what we'll type into here. Click that. And STM32 cores by STM Microelectronics, just like so. I think just double checking that all of that is correctamundo. Yeah. I'm going to go ahead and click install on that. This might take a second to install. Yeah, so far I look like I know what I'm doing. I can assure you that all of this configuration stuff is typically the most frustrating part of my job. Windows is not too bad. If you're ever trying to install software on Linux, I've learned that you're going to have a bad time. Particularly if you have like a AMD chip or something on your computer. Yeah, Windows, not too bad. But yeah, you can do this all in Linux. In fact, that's typically the Arduino IDE. Like my programming interface, I typically use the in Ubuntu 18 environment for most of my Arduino programming. I have a little station over here that I do all of the electronics work, and typically when I'm doing embedded programming, I'll do that there. So we are still downloading. And you can see in this background here we have all of these boards available. Let's see if I'll have to try to remember which board we have, but it's the Nucleo 32 L432KC. So once this gets done downloading, we'll need to go in. We should be able to just go into the Tools, click Board, and then go all the way down until we see this Nucleo L432KC. One thing I've noticed sometimes when we're installing this is that the software won't directly upload from the Arduino IDE. Like sometimes, this is what you need in order for it to compile. But I have had sometimes, depending on what computer I use, sometimes I have problems uploading straight from the Arduino IDE. If that happens, If that happens, what you'll need to do is go find where, for your particular Arduino package, where it's storing the binaries for that compiled package. And then you'll need to just copy that binary. It'll literally be .bin, and copy and paste that into the STM32, like this thing right here. So whenever you plug in your actuator, you plug in the STM32 into the USB in your computer, you can actually just copy and paste a binary and just drop it right in here, and it'll automatically upload it. So if you do have problems uploading, and if we have problems uploading, again, I don't think we will, because this is all through Windows, and Windows tends to play pretty nice with this kind of stuff. But if you do have that problem, go find, typically, like when you compile your Arduino, you might have to just Google some of this stuff, but when you compile the Arduino package, your Arduino program, it will save that somewhere in some temporary folder. It's going to be different depending on your package, depending on what operating system you're using, etc. Find that binary, just copy and paste it into here. It'll automatically start uploading it. It'll eject the image or the device or whatever, and it'll automatically put it back in. And then whenever it reloads, it won't have it here anymore, and that's actually good. That means that it uploaded just fine. So really, that's the only problem that I've had in the past with this kind of stuff. It seems to be going fine. We are installing. I'm all out of things to make small talk with. Let's see. Hopefully it won't take too long. It's still warm. There we go, installing boards. I mean, I guess I can talk a little bit about kind of Slate Robotics design philosophy. You'll notice that the TR2 is very actuator-centric, meaning that we've designed one single actuator and reused it multiple times throughout the entire robot. That is an important design consideration that it's very important to us, because if you want to have low-cost robotics, what you really need is you need some sort of similar design pattern that's reused. You need reusing parts. What can typically happen with most projects that people take on, if it's like the first robot that you design or something like that, people will design it kind of haphazardly, kind of ad hoc. They'll take I want it to look like this or something. They'll take a normal, I want it to look like a human arm or something. And then they go, okay, where do I put the motors for everything? Where do I put the encoders? How do I run the wires and stuff through there? And so what you get is this really, really complicated design where each joint is different than the one before it. The attachments are different. The power transmission is different. The gearing, everything is different. About them. So what we've done instead is just design one actuator and reuse that through the entire arm. So you have literally, you get huge complexity reduction by doing that. You know, just the number of unique parts that you need for one robot is tremendously lowered. You know, our TR1 robot, the first robot that we designed and built, that was all very ad hoc. You know, each joint was designed differently, everything was designed differently, and it was a nightmare. You know, you had hundreds of unique parts throughout the entire robot. But, you know, with this actuator, we have, you know, just a handful of parts, and then those get to be reused. So if you have certain problems, you know, you're trying to design around certain constraints, all of that design and engineering time gets to be magnified. You know, it all gets put into just one little device. All right, here we go. We are done with that. So hopefully now I can go here to Tools, click Board, and go down to Nucleo. You should see this new STM32 boards section. We did not have this before. Now we have Nucleo 32. That is what you need to click there. You should go to board part number. Go over here to Nucleo L432KC. That is a particular board number that we have. Let's see. Upload method, mass storage. That is good. And hopefully we have a port available here. Let me see if I can open up serial monitor and get anything. I don't think... Let's see. The baud rate of these is 115200. But I think I would have to restart it. All right, let me go ahead and try to upload some code to this thing. Okay, so based on the configuration that we just did, we should be good to go with programming. All we need to do is just get the code that is currently running on it, make whatever modifications we want, and go from there. So we are going to git clone https://github.com/Slate Robotics/TR2-embedded. Again, these links should be in the description. Just like that. And now I can go and open up the package that we need. So I am in Documents, GitHub, TR2 embedded. So this is the GitHub repository that I just cloned. We are dealing with actuator, so we're going to click on actuator slave, and we're just going to open up this actuator slave.ino. .ino is a package, just the name of the package. What is that? The file name of the package. Okay, so we should be good to go. We've got our software here. Let me go ahead and make this a little bigger. And that is it. I'm going to upload this, and I think we should get something printing. Yes. So here on the setup, we have serial.begin. This is the baud rate, and then it should print out starting, and then the actuator ID, and it's going to go through and all the config, try to connect to the network and all that kind of stuff. So we've selected our port, and this is go time. Hopefully this works. This has been a smooth video so far. It's been kind of slow installing some of the stuff and downloading all the things. But if this works, this is a really smooth video, and I look like I know what I'm doing. Let's see. Wow, it's only already 20 minutes recording. Will it be less than 20 minutes for this? It's not unusual for this to take a long time the first time it's compiling. What you'll notice is that when you compile it the first time, it's slow, and then, you know, for instance, if I go in and change this actuator ID, which I'll get into what this means in just a second, and then I click re-upload, we'll find that it compiles much quicker, because the compiler knows all it needs to go in and do is just change this little value, and it won't recompile the entire sketch if it doesn't need to. Yeah, this isn't the best computer either, which might not help, but we are getting there. I talked before about how much I hate the AMD. Boy, I'm lagging quite a bit too. Yeah, I hate the AMD chips. This thing runs on an AMD processor, and it's horrible. Cool, we compiled, we're uploading, and done uploading, starting actuator ID. Perfect. That means everything went exactly according to plan. And it is going to go into its whole process, and you can see all the code, and I'm not going to go into exactly everything that's going on in the code right here. I can tell you, sorry, a little bit. The code is a little messy, like particularly this first page, but I do have all these classes, and hopefully that clears things up for you a little bit. So I apologize. I can make another video talking about what's going on here. But you'll see this actuator ID. We start with A0 for the first joint in the arm. And then it goes A1, A2, so A0, A1, A2, A3, A4, so that's the 5 actuators. And then G0 for the gripper, B0 for the base, H0 and H1 for the head. So head, the neck is H0, then the neck tilt is H1. So those are the actuator IDs. So if you're, depending on which actuator you're uploading for, you'll need to change this value, because this will determine how it connects to the network. So we can change that to A3, and we'll see that it'll once it's done uploading, that value will change over here. And while that's compiling, well, looks like it's already compiled, so I'll wait on that for just a second. Okay, and there we go. Starting actuator ID A3. So again, this needs to be A0, A1, A2, A3, A4, B0, G0, H0, H1. So we need this actuator ID. And then we'll see this SSID and password for the actuator network. This is the credentials it uses connecting to the Raspberry Pi that's embedded on the TR2. So the way this works, you have the NVIDIA Jetson that talks to a Raspberry Pi over Ethernet. That Raspberry Pi hosts a Wi-Fi network that all of the actuators get to connect to on the TR2. So these are the credentials for that network. This is the SSID, and this is the password. If you forget your password or SSID, you'll need to go into your Raspberry Pi, SSH into it, and let's see, what file is that? It's .conf. There's a configuration file that stores the credentials. Anyway, just message me if you forget that. But in there, it has the SSID and password or passphrase that's being used for that broadcast Wi-Fi network, and basically that needs to match. This needs to match that, because the actuator will not be able to connect to the network unless this is the same as what the Raspberry Pi is using. So that's really it. We've got our actuator connected. All I need to do, just unplug that from the Wi-Fi, grab my actuator, and we're good to go. And you can go in, make any changes you want, have fun. All of this is open source. Have at it, change it, use it. I don't care. But of course, if you screw anything up, that's on you. But you can always go in and check out the code. And if you do mess up, you can just re-upload it with the original code. So hopefully that's not too bad. But anyway, that pretty much concludes it. Thanks for sticking along on this video. It's been a little long, but hopefully that covered all the bases, and hopefully you guys don't have any issues getting to what I just got to in this nice little 25-minute video. So you guys have a great day, and I will talk to you next time.